Hi, welcome back. Today, you will learn understanding and creating classes.
So I've hinted at the idea of classes and methods and properties throughout this series already. I've noted that the .NET Framework class library is written using classes and methods. And we've benefited from classes and methods many times already. Now it's time to dive deeper to really understand the role of classes and how they differ from objects, and how to define your own classes and create new instances of those classes in memory. As you'll come to learn, virtually everything in the .NET Framework is a class or a part of a class. That's really the purpose of this lesson. Not so much that you can create your own classes necessarily, create your own framework, although that probably will be required to some extent as we move through the rest of these videos. The intent is really to use the classes that were already built by Microsoft and that are made available through the .NET Framework base class library. The truth of the matter is that I couldn't possibly cover everything there is to cover about classes because it's a vast, vast topic. If you really want to learn about the power of classes, then you're going to need to learn more specifically about object-oriented programming. That's a topic for another day. I just want to present enough information for you to become comfortable with the basics of how to use existing .NET Framework class libraries, as well as how to create super simple classes as a means to coming to a more full understanding about what's going on in the .NET Framework class library. But again, I suspect that as you move past this initial series of videos, you'll want to start thinking about your business rules and how you represent the logic of your application in terms of objects that interact with each other. Okay? More about that later. So let's do this. We're going to start by creating a new project called Simple Classes. So suppose that I want to create an application that works with cars. I may have a car lot, and I need to keep track of an inventory of all the cars that are for sale on my car lot. So to keep all the related information about a single car kind of in one container that I can keep kind of self-contained, I might want to create a class that represents a car. So I'll create a car class. And so we're going to define a car class in a class file called car.vb. And the way to do this in Visual Studio, there's actually a couple of ways to do it. What I prefer to do is right-click on the project name in the Solution Explorer and select Add. And I could select New Item, but there's also a shortcut just to select Class. You can see there's even a shortcut, Shift-Alt-C, if you remember shortcuts, to create a new class file. Either way, it'll pop open an Add New Item dialog with class already pre-selected. And here we'll just want to rename this class1.vb to car.vb. And when we do, we see we have the new car.vb in our Solution Explorer. We have car.vb open in the main area, and we have this public class car with an end class kind of to define this, this code block. And so the keyword class will tell the compiler what type of code block we're attempting to create. We're going to give this code block a name called car. And so we'll see how this is used in a later step. And so we're going to add new properties and methods between this public car class and car class. And properties and methods are simply the members of the class. So classes can contain lots of different kinds of things, other kinds of members, but these two are the most popular, properties and methods. There's also fields and events and maybe some others. So in this lesson, we're going to create 4 properties that describe the car: the make of the car, the model of the car, the year the car was built, and the color of the car. Now, we might model more of these if we were to really flesh this example out, but this will suffice for our purposes. A property defines an attribute of an object or an instance of the class. Now, how do we describe a car in this particular case? Well, there are many ways to describe a car, and you can choose those attributes that make the most sense for the type of application that you're building. Since this application is going to help us to manage cars on a car lot, we don't need to model all of the attributes or all of the actions that describe a car. In other words, we may not care about its fuel efficiency. We may not care how fast it can accelerate. We may not care or we may not model the fact that it can take the action of accelerating or decelerating. So other types of applications related to cars might need to model this information or these actions. But again, for our purposes, we really only need to model those attributes and actions, or rather those properties and methods, that'll help us keep an inventory of cars on our car lot. All right? So what do you do with a property? Well, a property is a lot like a variable. You can set the variable, or you can retrieve values from the variable. So you can set an attribute or a property in code, or retrieve the attribute or the property's value in code. Exactly how you would work with variables. It's just that this variable is defined inside of a class. Okay? There's a little bit more to it than that, but that's basically it. So that's a property. A method defines a named body of code and typically represents something the class can do, an action that it can take. So we've already seen subprocedures and functions. It's exactly the same, except in the body of this car class definition. There's a little more to it than that, but that's basically the idea. We've created helper methods in the previous lessons to do something meaningful, like perform some super secret formula calculation, right? In our car class, we're going to create a method that will determine the market value of the car based on some criteria, some business rules that we're going to come up with off the top of our heads that will help us determine the value of the car on our car lot. That makes sense in the context of a car lot inventory management system, right? All right, so we're going to start by creating some simple properties. And there are different ways to define a property. I'm going to take the easiest approach to defining property called auto-implemented properties. I'll show you the long form in just a moment, but let's start really simple. In fact, let me capitalize the M in make, and I'll describe why I do that a little bit later. Great. All right. There's also a longer form. These are auto-implemented properties. There's a longer form that you might wish to employ in more advanced scenarios. I really just want to show you this exists, and then after I show this to you, I want you to completely forget about it, okay? Again, advanced scenarios, but you might see this defined in code examples that you look at out on MSDN or out on the internet at large, so I want you to be aware of it. Fortunately, you don't have to memorize the syntax because the Visual Studio IDE has a built-in code snippet called prop, short for property. So if you do this, you type in prop, you can see that tab twice at the very bottom of that little box that pops up. Tab twice to insert the property snippet. All right, tab, tab. Wow, it expands out to quite a bit of code. And all of those yellow areas are replaceable. You can use the tab key in your keyboard to kind of tab in between which one you want to change. And so let's go ahead and modify this, and I'll explain the different parts of this. What we're going to do is, and I'm going to throw this away, but we'll create a property called Blue Book Value. So that'll be there's the Blue Book that tells you the real value of cars out on the car market, I guess. I don't know much about it, but okay, here we go. I'll use an underscore, Blue Book Value, and then I'll use the tab. And since I want this to represent a monetary value, in Visual Basic you use the decimal data type to represent both whole numbers and decimal values. That will give you dollars and cents. So we'll go decimal, tab, and I want to call this Blue Book Value, tab, tab. All right, it looks good. Okay. So what we've done here is define two structures. The first will actually hold the value. It will be what's called a private field. And a field is usually a backing value for a public property. A public property in this context is a gatekeeper that restricts or enables access to the actual value that's stored and hidden, encapsulated behind these gatekeepers, these gets and sets. And get and set are the two actions that you can take on a variable, or rather a property. You can get the value that's currently stored inside of the property, or rather in the field. You can see where we return what's ever in that private field called underscore blue book value. Or we can set whatever the value is will be passed into the set. So I want to set blue book value equals 2000. 2000 would be passed in as the value and set to this private member underscore blue book value. All right. Why this occurs again is advanced. That's why I didn't really want to talk about this much, but think of these as gatekeepers. I can control access to blue book value, underscore blue book value, by writing more code in the get and the set. So for example, a car's value should never be a negative number. So we might want to restrict that in the set. We check value if value is greater than 0, then we'll allow the blue book value to be set. Otherwise, we'll just ignore whatever they attempt to set the value to if it's a negative number. Okay? That might be one way that we do this. The get, we can control access maybe by checking the permissions of the current user. Do they have access to the current blue book value of the car? Well, if not, we're not going to let them have it, right? We'll just return nothing, or we'll return 0, or something to indicate, or we'll raise an exception. You don't have access. Why are you asking this question? All right, now everything I just told you, completely forget about it, okay? We're not going to talk about that much more in this series of lessons, but this is the notion of encapsulation. It's one of the tenets of object-oriented programming, okay? And we control access a number of different ways, through getters and setters, through public and private, and therefore you see these two keywords, public and private. You saw public here, right? It even affects how we name things. For example, I changed the M in make from a lowercase m to a capital M because a naming convention in Visual Basic and most programming languages is to have public properties represented with a capital letter in the camel case. So the capital letter is the first letter, as opposed to a lowercase letter, which would indicate a private member. Also, the underscore represents a private member that shouldn't be accessed directly from outside the class, and therefore that's why it's marked as private, and there's an underscore within the naming convention. All right, now forget everything I just said, okay? We'll either come back to it or we won't, but either way, it won't really be pertinent for the remainder of this. All right, so let's continue on. The application we're building here is going to keep an inventory of all the cars on our car lot. So as the developer, I need to collect some basic information about each new car on my car lot. So now to make this a real application, I might pop up a user interface to the end user who's taking in an inventory of all of our cars and allows them to type in information about the make, the model, the year, and the color of a given car on our car lot. We could make that in the form of a web page, as a Windows application, a Windows Phone application, whatever the case might be. But for now, we're going to keep it simple and just use our car class and hard code some values directly into our submain. Okay? And so what we'll need to do is, to begin that process in my program, I'm going to create a new instance of the car class for each new car that I want to work with in my application. So I will do the following. All right. So here I'm creating a new instance of my car class. So an instance of a class is called an object. An object is not a class, and a class is not an object, although you'll hear people, even me, kind of use those synonymously or maybe even confuse the two terms. The class is the blueprint. An object is instantiated from the blueprint. You can think of the class as a pattern, and an object is an instance of that pattern where you actually cut out the fabric according to the pattern and you sew it together and you have a dress or a pair of pants or whatever the case might be. So once you create a new instance of a class and give it a name like this, my new car, it creates an area in memory sufficiently large enough to hold an instance of the car class, and now I can manipulate the properties of that class by using its moniker, its variable name, my new car. So let me explain this difference between the class and the object so you get this firmly cemented in your mind. In the real world, you can use the same blueprint to create many new houses. On my block, there are several houses that look exactly like my house, okay? They have the same layout, they have different color bricks maybe, but they're essentially the same house. So you can use the same blueprint to create many instances of the house, or you can create the same article of clothing over and over by using the same pattern. Or you can use a recipe many times to create the same cake or casserole for different meals. So each time you want to build a new house, it'll be at a new address. There's only one instance of this house at this street address, okay? It's not possible to put two of the same houses on the same address, right? That wouldn't make sense. Each time you follow the pattern, you create a new instance of clothing that can be sold to a different customer. Each time you follow the recipe, that new instance of the recipe can be offered at a different meal. So the same is true with classes. Each time you create a new instance of the class, you have a new object that's distinct and separate from other instances of that class that are all in memory. So think of a class like a cookie cutter. You can't eat the cookie cutter. You can eat the cookies that are made from the cookie cutter. So when you instantiate a class, you create a cookie, the instance, based on the shape of the cutter. In this case, it would be a finger shape. But imagine a heart shape or a star shape or whatever the case might be, and then you have instances of those, many of them potentially, right? So as you take a look at this line of code, we have this keyword new. So think of the new keyword as a factory. It uses the blueprint, the car blueprint, to create a new instance of the car class. So think of it as it's a factory that uses the pattern to create a new article of clothing. It uses the recipe to create a new casserole. It uses the cookie cutter to create a new heart-shaped cookie. Okay, that's what the new keyword does. It's the factory that pumps out a new instance of whatever the pattern is, right? So it brings the class to life in the computer's memory and makes it available and usable now. So you can create many instances of that class, so you can create many objects, all based on the same class, but each one might be distinct from the others based on its unique settings in its properties, okay? So in my code, I'm going to set each of the properties of my new instance of car, called my new car, to the appropriate values. Admittedly, in this case, I'm just going to hard code the values in here. In a real world application, I would present a graphical user interface like a web page or a Windows form to collect this information from an end user, or I might pull it from a database or whatever the case might be. So as I type out this example, notice that the dot operator, the period, is the way that you get to the properties of an instance of a class, or it's the way that you get to the properties to set them or get them for an object. And when we do that, my new car, you can see that we're now able to see all of the members of that instance of that class that are available. So before I actually do this, let me kind of back out of that 1 second here, and I'm going to show you a shortened version of this. We can simply represent my new car as car equals new car, like so. And this does essentially the same thing, and we can lose the equal sign, okay? All right, now I'm going to set all the properties of my new car. Great. So let's take a moment to dissect this code and really understand what's going on. First, I use the name of the instance of the car class, my new car, to access each of the properties of the car class that I'm going to set. And I use the equal sign, just like I do with variables, as the assignment operator. I'm assigning a new value to each of the properties of an instance of the car class. These new values for each property are maintained in memory for this instance of the car class, and as long as I have a reference, in other words, as long as I hold on to my new car, that instance of the car class will be maintained in memory, and so I can retrieve values from the properties that I set or change them again, whatever the case might be. So once I have a new instance of my car class and I've set its properties, I can do some useful things with this instance of the car that I've named my new car. For one thing, it's a nice collection of all the related properties that define a single car, all in one container, in this my new car container. And so here I've set the properties. Let me show you that I can also retrieve the properties, and I'll just print them out to screen like so, using console.writeline, and we'll use that string formatting characters like we've or replacement characters like we've done in the past. So my new car dot make, my new car dot model, my new car dot year, console. Great. Let's run our application just to prove that it works. And it does. All right. So think about what's going on here. Again, in lines number 8 through 11, I'm setting the properties. In lines 13 through 16, I'm retrieving the properties for use to print out to screen. So that's why we saw the get and the set in the full property definition just a moment ago. They describe the two actions that you can perform on properties. So when I create a custom class, in other words, whenever I create a class myself, as opposed to using a class that's already been created in the .NET Framework-based class library, I've really created a custom data type, just like any other data type that I've been using in my applications up to now, like string or integer. Therefore, I can define method input parameters like on helper methods, or I can define return values for helper methods that use that new custom data type. So let me do this. I'm going to create a helper method. I'll do this below the end sub, but before the end module. And I'm going to call this function determine market value. And I'll return a data type of decimal, which I'll use for monetary values. So if I want to represent money in Visual Basic, the typical way you do it is through the use of the decimal data type. All right. And what I'm going to do is I'm going to allow the user of this helper method to pass in an instance of type car, not type string or type integer, which are built-in data types, but of type car, which is my custom data type. And I'll do that like so. And I'll just call this input parameter my car. Let me come back to that idea in just a moment. All right, let me hide that. Great. So I'm going to need to perform some super secret formula that'll help me determine the market value of a car. I tell you what I'm going to do. I'm going to just do something extremely simple and just return some value, $100. Every car is worth $100 on our car lot. Okay, obviously silly. We'll come back to that and change it a little bit later. All right. So the key idea here is that you can use your new class that you've defined, car.vb, anywhere you would need a data type, whether that be in defining a function as an input parameter, defining the return value. We could return a car from our helper method if we wanted to. All right, I don't know why we would, but we could do that. Let me address this use of the term my car here. Many times input parameters use an underscore with the same name as the data type itself. So it might be more proper to do something like that, at least as some people are concerned. I've also seen people who describe the purpose of the input parameter like so, something like car to be evaluated, all right, and then we could use that variable in the body of our code block. Now, I prefer using the my prefix in Visual Basic because underscore has another meaning to many developers. Like you saw a moment ago, we used it to define a private member field, Blue Book value, underscore Blue Book value. But these are known as naming conventions, and there's a bunch of them, and developers get into heated arguments about it. So my suggestion is use whatever your teammates want to use if you get a job and you're working with others, especially at first. It really doesn't matter which naming convention that you choose, as long as you apply it consistently in your application and everybody who's working on it understands that naming convention. All right, so back to the matter at hand. Whenever I want to call this helper method, I just simply pass an instance of the car class to it, and it will do the rest. So let's comment this line of code out, and I'm just going to do console.writeLine, and I'm going to call determine market value. Which car am I going to determine the market value of? We'll pass in my new car and see how much it's worth. And we already know what the answer to this will be. It'll be 100 every time. Okay, but hopefully you get the idea. Again, the key idea here is that you can use your data type, your new class, as any type of data type that you want to for any purpose. So I said that classes are comprised of properties and methods, but we haven't created any methods yet. So let's create a new version of this determine market value. I'm going to copy this, and I'm going to paste it into my car class definition. And let me change some things about it. First of all, I'm going to change its name from lowercase d to uppercase d, and I'm going to mark this function as a public function for all the reasons that we talked about before when we were talking about private and public, and we'll discuss that at much more length in the future when we discuss visibility modifiers, and we'll devote almost a whole lesson to that topic. But for now, let's comment out our super secret formula, and let's give it a more interesting set of business rules. So dim car value as decimal, and then if, and I want you to notice how I'm going to access the year for a instance, this instance, whatever this is, of the car class. So I'm going to say, what is my year? If my year is greater than 1990, then do something else. So here, let's set car value here. If it's before 1990 or greater than 1990, rather after 1990, we'll set it equal to $10,000. And if not, then we'll set car value equal to 2,000. And again, pretty simple super secret formula, but it's a little bit better than just returning us one value no matter what. But again, the me keyword here, first of all, it's optional. We could do this and it would work just fine, but the me keyword is a little bit more expressive as far as I'm concerned. It allows me to tell you, when you're looking at my code, that this year is actually defined as a member of the class. If I didn't, you might have a hard time understanding where this year magically came from, especially if there's a lot of code. So me says it's a member of this class, and I want to look at the current instance of the class and use its year property to determine something about the car value that will return back as a decimal. All right. So I strive to go overboard to make my code obvious and readable for my future self, as well as anybody else who might look at my code. And then finally what I'll do, now I'm going to use that new method here, console.writeLine, and I'll do something like cars value, and we'll represent it as we learned about in the previous lesson, and we'll call my new car dot determine market value, like so. And let's run the program now. Whoops, what did I do wrong? Oh, we're missing a return statement. Return car value, like so. We have to actually return this out to satisfy the return type. So now let's run our application. And one other thing that I forgot to do is that we no longer need to pass in my car, because we're going to be working with this instance of the car class that's associated with the car class, okay? So we don't need to pass in an input parameter. So now let's run the application, and we can see that the car's value is $2,000 because it was created or built before 1986. Okay, all right, so let's stop there. We've discussed the absolute basics of classes and objects, the role of the new keyword. We discussed properties and methods and a lot more. As I recap this lesson, let me point out that we used a very concrete example in this lesson, that of a car. A car is easy to conceptualize and represent in a class because it's tangible and it has a real-world equivalent. But most of the time, whenever you're working with the .NET Framework class library, you're going to be working with classes that do not have real-world equivalents. In other words, they're more conceptual in nature. For example, I might work with a class that represents a connection to the internet, or a stream of data, which is sort of like a pipeline of data flowing between one place and another. Or I might have a class that represents a span of time, again, conceptual in nature, the time span class. In these cases, we're not working with something tangible in the physical world. So keep in mind that a class can represent something tangible, but more likely, as you'll be using it, something that's intangible. It really depends on what you're trying to model. It can be challenging in both cases, both tangible and intangible, to decompose a problem into classes. Unfortunately, there are skills that you can develop to help you identify different classes in a system and then delegate responsibilities to them. This process is called object-oriented analysis and design. Again, that's not something that we're going to cover in this series of lessons, but you can learn more about them through books, and I also cover that topic on my own website, www.learnvisualstudio.net. So to recap, a class is a data type in .NET similar to those basic data types that you've been using up to now, like string and integer. You can define custom classes with properties and methods and then create instances of classes, or rather create an object using the new operator, which we said was the factory that actually stamped out a new object and put it into the computer's memory and retrieve back a reference to that object so that now we can work with that object in memory. More about that in the next lesson. You can access the object's properties and methods using the dot operator, which we know is the member access operator. So there's still quite a bit to say about classes. We're going to pick up this idea in the very next lesson. We'll see you there. Thank you.